There's something about the cosmos that refuses to let us look away. Every time we think we've unraveled its secrets, the universe throws another curveball, a strange signal from deep space, a star that flickers in ways it shouldn't, or a galaxy that defies every rule we thought we knew. These aren't just glitches in the data or gaps in our understanding. They're real, tangible mysteries that leave even the brightest astronomers scratching their heads. And the deeper we peer into the void, the more we realize just how much we still don't know. Take a moment to picture this. You're floating in the silent blackness of space, surrounded by countless stars, each one a sun with its own stories and secrets. But among them, hidden in plain sight, are anomalies, things that shouldn't exist, events that shouldn't happen, phenomena that defy logic itself. Some of these cosmic oddities are so bizarre that they've stumped scientists for decades. Others are so new that we're still scrambling to make sense of them, and that's exactly what makes them so thrilling. Because every unexplained mystery is a doorway, a chance to rewrite what we thought was possible. Today, we're diving into 25 of the most mind-bending space anomalies ever discovered. These aren't just quirks of the universe, they're full-blown enigmas that challenge everything from physics to our very understanding of reality. Some might hint at forces beyond our current science, others could be clues to something far bigger, something waiting just beyond the edge of our knowledge. So whether you're a seasoned stargazer or just someone who loves a good cosmic mystery, get ready. Because the universe is about to show you just how strange, how beautifully inexplicable it truly is. The universe has sent us one tantalizing message that we still can't decode: the wow signal. Back in 1977, the Big Ear radio telescope in Ohio picked up something extraordinary. A burst of radio waves so powerful, so precise, that the scientist who discovered it scribbled, "Wow." Right on the printout. For 72 seconds, this signal blazed across the cosmos, matching the exact frequency scientists predicted an alien transmission might use. And then nothing. It never repeated. No follow-up, no echoes, just silence. Think about that. A signal that strong doesn't just happen by accident. It was 30 times louder than the background noise of space, narrow in frequency, just like a deliberate broadcast. And it came from the direction of the constellation Sagittarius, where hundreds of thousands of stars could host worlds far older than ours. Was it a greeting? A cosmic flare? Even now, astronomers debate it. Some say it could have been a natural event, like a comet's hydrogen cloud reflecting the sun's energy, except no known comet was in that spot at the time. Others argue it might have been a one-time interstellar phenomenon, something we simply don't understand yet. But here's the real kicker: despite decades of searching, we've never heard anything like it again. Not from that patch of sky, not from any other. The wow signal is a cosmic flare that burned out before we could trace its source, leaving us with just one undeniable truth: sometimes the universe whispers something we're not meant to hear twice. While the wow signal left us with an unanswered question, there's another cosmic mystery that's been playing out right before our eyes, one that makes even seasoned astronomers question what they know. Meet Tabby's star, officially known as KIC 8462852. This unassuming flicker in the constellation Cygnus behaves like no other star we've ever seen. Most stars dim slightly when planets pass in front of them like clockwork, but Tabby's star, it doesn't just dim, it plunges. Its light drops by as much as 22% at times, in irregular, jagged patterns that last for days or vanish in hours. At first, scientists thought it might be a swarm of comets, thousands of them, drifting in front of the star and blocking its light. But comets don't explain the sheer scale of dimming or why the star's overall brightness has been fading over the last century. Then came the wilder idea: what if something artificial was causing it? Some researchers floated the possibility of an alien megastructure like a Dyson sphere, a hypothetical energy-harvesting shell built around the star by an advanced civilization. The idea set the internet ablaze, but it hit a wall. Even the most advanced telescopes couldn't find the infrared heat such a structure should radiate. Now, the leading theories point to cosmic dust. Tiny particles, unevenly distributed, could scatter light in unpredictable ways. But here's the catch: the dust would need to be finer than anything we've seen in our own solar system, and it still doesn't fully explain the star's long-term fading. Every explanation we've thrown at Tabby's star comes up short. It's as if the universe is teasing us with a puzzle we're not quite smart enough to solve yet. And that's what makes this star so fascinating. It's not just an anomaly, it's a reminder that even in a cosmos we've studied for centuries, there are still phenomena that leave us utterly stumped. If you thought the mysteries of deep space were strange, wait until you hear about the enigma that might be lurking much closer to home: the Black Knight satellite. This legendary object is said to be an ancient, alien-built satellite silently orbiting Earth, watching us for thousands of years. The stories around it are the stuff of science fiction, except some people swear it's real. The legend began in 1954 when newspapers reported that the U.S. Air Force had detected two mysterious satellites orbiting Earth at a time when no country had the technology to launch one. Then, in 1960, a strange, dark object was photographed during a space mission, a silhouette against the void, appearing where nothing should have been. Conspiracy theorists latched onto the images, claiming this was proof of an extraterrestrial presence, perhaps monitoring humanity for millennia. Some even say Tesla picked up its signals in the early 20th century, calling it an intelligent control from beyond Earth. But here's where the story gets murky. NASA and astronomers dismiss the Black Knight as nothing more than space debris, a lost thermal blanket or discarded satellite part catching the light at odd angles. Skeptics point out that the famous photo looks suspiciously like a piece of equipment from a 1998 space shuttle mission. Yet believers counter with radar anomalies, unexplained signals, and the fact that similar sightings date back centuries in historical records. So what's really up there? The truth is, we may never know for sure. The Black Knight exists in that hazy space between myth and reality, where every dismissal only fuels more questions. Whether it's an alien artifact or just cosmic junk, one thing's certain: it keeps us looking up, wondering who or what might be looking back. Just when we thought our solar system had seen it all, in 2017, astronomers spotted something that shattered expectations: a visitor from another star. Named Oumuamua, Hawaiian for scout or messenger from afar, this strange, tumbling object became the first confirmed interstellar traveler ever detected passing through our cosmic neighborhood. At first glance, it seemed ordinary enough, a reddish, elongated rock hurtling through space, but the closer scientists looked, the weirder it got. Oumuamua didn't behave like any comet or asteroid we've ever seen. For one, its shape was all wrong. Most space rocks are lumpy or round, but this thing was bizarrely stretched out somewhere between 6 and 10 times longer than it was wide, like a cosmic cigar tumbling end over end. Then there was its speed. As it slingshotted around the sun, instead of slowing down like a typical comet, it unexpectedly sped up as if pushed by some unseen force. Comets usually get a boost from evaporating ice, which creates a visible tail, but Oumuamua had no tail, no gas, no dust, nothing to explain its sudden burst of acceleration. That's when the theories really took off. Harvard astrophysicist Avi Loeb made headlines by suggesting the unthinkable: what if Oumuamua wasn't a natural object at all? What if its strange movement and shape hinted at alien technology, maybe a discarded light sail or a derelict probe from another civilization? The idea sparked fierce debate. Mainstream astronomers pushed back, arguing it could still be a rare type of comet, one that vented invisible hydrogen gas or had an unusual composition. Others proposed it might be a chunk of frozen nitrogen, sheared off a Pluto-like exoplanet millions of years ago. But here's the twist: we'll never know for sure. Oumuamua raced out of telescope range before we could study it in detail, leaving behind more questions than answers. Was it a cosmic fluke, a fragment of some distant world? Or was it, as Loeb insists, our first brush with evidence that we're not alone? Either way, Oumuamua forced us to confront a humbling truth. Sometimes the universe sends us mysteries we're just not ready to solve. And that's what makes this strange visitor unforgettable. It didn't just pass through our solar system, it passed through our understanding, leaving a trail of wonder in its wake. After Oumuamua left us questioning whether we're alone in the universe, there's an even bigger mystery that haunts astronomers, one so perplexing it has a name: the Fermi Paradox. On paper, everything suggests the cosmos should be teeming with life. The universe is unimaginably vast, with billions of galaxies, each holding billions of stars, nearly all with planets. Statistically, Earth shouldn't be special. Intelligent civilizations should have risen countless times over the universe's 13.8 billion-year history. So where is everybody? Why does the universe feel so empty? The paradox gets its name from physicist Enrico Fermi, who famously asked, "Where are they?" During a casual lunchtime conversation in 1950, his point was simple: if advanced civilizations exist, they've had more than enough time to colonize the galaxy. Even at modest speeds, a civilization could spread across the Milky Way in a few million years, a blink in cosmic terms. Yet we've found no signatures of alien megastructures, no interstellar messages, no traces of distant engineering. Just silence. Scientists have proposed dozens of explanations, each more unsettling than the last. One leading idea is the Great Filter, a hypothetical barrier so deadly it wipes out civilizations before they can expand. Maybe it's the rise of intelligent life itself, a fluke so rare we're the only ones who made it. Or perhaps the filter lies ahead of us, something like runaway AI or nuclear war that dooms every civilization before they reach the stars. Then there's the darker possibility. What if we're being avoided? The zoo hypothesis suggests advanced civilizations know we're here but deliberately stay quiet, observing us like animals in a cosmic wildlife preserve. Others think we might be hopelessly primitive, like ants trying to notice humans too small, too slow to even recognize the signs of a galaxy-spanning intelligence. But the eeriest solution might be the simplest. What if we truly are alone? What if Earth is the only place where life ever took hold? The silence of the universe could be a warning, not that others have vanished, but that life itself is vanishingly rare. The Fermi Paradox isn't just a question. It's a mirror forcing us to confront how little we understand about our place in the cosmos. And until we find proof otherwise, that silence will keep echoing back at us. Deep in the fabric of space, something impossible is happening. Entire galaxy clusters are racing toward a point we can't see, as if dragged by an invisible hand. Astronomers call it dark flow, and it's one of the most unsettling discoveries in modern cosmology. Picture this: the universe is expanding as expected, but certain clusters, thousands of them, aren't just drifting apart. They're all moving in the same direction at breakneck speeds, like leaves caught in a cosmic river current. The strange part, there's nothing there to pull them. No supercluster, no massive structure, not even a void, just empty space. This bizarre motion was first spotted in 2008 when scientists studying the cosmic microwave background, the afterglow of the Big Bang, noticed something off. Galaxy clusters were streaming toward a spot near the constellations Centaurus and Vela at speeds over 2 million miles per hour. That's fast enough to cross the Milky Way in a cosmic blink. At first, researchers thought it might be a glitch, an error in the data, but follow-up studies only confirmed it. The flow exists, and it defies everything we know about how gravity and motion work on the largest scales. So what's tugging on these galaxies? One radical theory suggests the pull might come from something outside our universe entirely, a neighboring realm in the multiverse, exerting gravitational influence beyond the edge of our observable cosmos. Imagine two soap bubbles floating close together. Even if they don't touch, the gravity from one could warp the surface of the other. If true, dark flow could be our first indirect evidence of parallel universes. But not everyone's convinced. Skeptics argue it might just be a flaw in our measurements or an undiscovered quirk of dark energy. Others propose an even wilder idea, that our understanding of gravity itself is incomplete, and Einstein's equations break down at these unimaginable scales. After all, why should physics behave the same everywhere when we've only studied a tiny fraction of the cosmos? The chilling truth is, we might never solve this mystery. Dark flow hints at forces or realms so distant, they're beyond observation by definition. It's like standing on the shore, watching waves roll in from a horizon we'll never reach. Whatever's out there, one thing's clear: the universe holds secrets we're only beginning to glimpse, and some of them might forever lie just beyond our grasp. There's a force lurking in the depths of space so powerful, it's dragging our entire galaxy, along with thousands of others, toward it at over 1 million miles per hour. Astronomers call it the Great Attractor, and it's one of the most baffling gravitational mysteries in the cosmos. Picture this: every galaxy in our corner of the universe, including the Milky Way, is caught in a slow but unstoppable cosmic current, all flowing toward a single point in the sky near the constellations Hydra and Centaurus. The strange part, we can't even see what's pulling us. That's because the Great Attractor lies hidden behind the Milky Way's own galactic plane, a region so dense with stars, gas, and dust that it's nearly impossible to peer through. Astronomers dub this blind spot the zone of avoidance, a place where our own galaxy's brilliance drowns out everything behind it. It's like trying to spot a lighthouse through a thunderstorm. But thanks to infrared and X-ray telescopes, we've begun to piece together what might lie in that shadowy realm. The leading theory: a colossal supercluster of galaxies, each one brimming with dark matter, combining their gravitational pull into something massive enough to tug on everything around it. The Norma Cluster, a dense knot of galaxies, sits near the heart of this mystery, but even that might not be the full story. Some calculations suggest the Great Attractor's pull is too strong to come from what we've detected so far. There could be something even bigger lurking in the darkness, something we're only beginning to map. Here's where things get stranger: the Great Attractor itself might not be the final destination. Recent observations hint that this entire flow of galaxies, ours included, might be part of an even larger cosmic tug-of-war, pulled toward an incomprehensibly vast structure called the Shapley Supercluster, over 600 million light-years away. It's as if the universe is built on layers of invisible scaffolding, with each tier of dark matter and galaxies exerting its own gravitational influence. But the real puzzle isn't just what's pulling us, it's why the math doesn't quite add up. The visible matter we've spotted in that direction can't account for the sheer strength of the attraction. That's forced scientists to confront the possibility that dark matter, the elusive substance making up most of the universe's mass, is clumped in ways we don't yet understand. Or worse, that our theories about gravity itself might need rewriting on these gargantuan scales. The Great Attractor is more than a scientific curiosity. It's a humbling reminder that even as we map the cosmos, some of its most powerful forces remain just out of sight, hidden behind the glare of our own celestial backyard. And until we find a way to see through that cosmic veil, the question will linger: what exactly is waiting for us in the dark? Imagine a flash of energy so intense it outshines entire galaxies, but only for a millisecond. That's the enigma of fast radio bursts, or FRB. These cosmic flashes erupt without warning, packing more energy than our sun emits in 80 years into a blink, and you'll miss it burst of radio waves. Discovered in 2007, they've become one of the most tantalizing puzzles in modern astronomy. What makes FRBs so baffling is their sheer unpredictability. Most appear as one-off events, vanishing as quickly as they arrive. leaving astronomers scrambling to trace their origins across billions of light years. But a handful defy the pattern repeaters that fire off multiple bursts from the same patch of sky. The most famous of these, FRB 121102, has been flashing sporadically since its discovery, like a cosmic lighthouse with no discernible rhythm. So what could possibly generate such violent, fleeting energy? The leading theory points to magnetars, highly magnetized neutron stars that occasionally unleash starquakes or magnetic eruptions powerful enough to rip spacetime itself. In 2020, astronomers caught a magnetar in our own galaxy firing off an FRB-like burst, offering the first direct clue. Yet even this explanation falls short. Some FRBs are far more energetic than anything a magnetar should produce, and their repeating patterns don't always fit the expected behavior of these stellar corpses. That's where the wilder theories come in. Could colliding black holes or neutron stars create shockwaves capable of generating FRBs? Or perhaps these bursts are the dying screams of evaporating primordial black holes, theoretical relics from the dawn of time. Then there's the most provocative idea: could some FRBs be artificial? Avi Loeb, the Harvard astronomer behind the Oumuamua hypothesis, has suggested that advanced civilizations might use focused radio beams to propel light sails across galaxies, with FRBs being accidental leakage from their cosmic engines. But here's the catch: the universe loves to humble us. The more we study FRBs, the stranger they get. Some arrive with a strange twist in their radio waves, hinting at extreme magnetic environments. Others seem to come from regions of space with no obvious galaxies nearby, as if the bursts are echoing from the void itself. And in 2022, astronomers detected an FRB inside a globular cluster, a densely packed group of ancient stars where magnetars shouldn't even exist. The truth is, FRBs might not have a single explanation. They could be cosmic breadcrumbs leading us to multiple undiscovered phenomena, each more exotic than the last. Every new detection chips away at our assumptions, reminding us that the universe still holds surprises we've only begun to imagine. And until we unlock their secrets, these millisecond mysteries will keep us staring at the static, waiting for the next burst to light up the dark. As the Pioneer spacecraft ventured beyond the reaches of our solar system, they carried more than just scientific instruments. They carried a mystery that would puzzle researchers for decades. Launched in the early 1970s, Pioneer 10 and 11 were supposed to coast smoothly into the void, their trajectories predictable under the familiar laws of gravity. But something strange happened. As they passed the orbit of Saturn, both probes began slowing down ever so slightly, as if an unseen hand was gently tugging them backward. This unexpected deceleration, barely noticeable at first, became known as the Pioneer Anomaly. At its peak, the effect was minuscule, about 300 billionths of the acceleration we feel from Earth's gravity. But in the precise world of astrophysics, even the tiniest discrepancy demands an explanation. For years, scientists scrambled to account for it. Was it a flaw in our understanding of gravity, a sign of some unknown force acting at the fringes of the solar system? Or could it have been the faint pressure of dark matter, slowing the probes like interstellar molasses? The official explanation, settled upon after years of painstaking analysis, seemed almost mundane: thermal radiation. The probe's radioactive power sources generated heat, which bounced unevenly off their asymmetrical bodies, creating a tiny but constant push in the opposite direction. Like a car idling with one window slightly open, the uneven pressure was just enough to account for the anomaly. Case closed, or so it seemed, yet not everyone is convinced. Some researchers argue the thermal explanation doesn't fully match the data, pointing out inconsistencies in the timing and magnitude of the deceleration. Others wonder if there's a deeper principle at play, something that might rewrite our grasp of physics in the outer solar system. After all, if we missed something as subtle as this, what else might be lurking in the equations we take for granted? The Pioneer Anomaly stands as a quiet reminder, even in the age of precision science, the universe still holds surprises. It's not the dramatic flash in the pan mystery of an FRB or the eerie silence of the Fermi Paradox. This was a whisper, a faint nudge against our assumptions, proving that sometimes the smallest deviations can lead to the biggest questions. And while we may have an answer on paper, the doubters keep looking because in the end, science thrives not on certainty but on curiosity. The moon seems like a quiet, unchanging neighbor, a lifeless rock locked in an eternal orbit around Earth. But beneath its dusty surface lies a puzzle that rewrites what we thought we knew about our closest cosmic companion. Billions of years ago, the moon wasn't just a silent sentinel in the sky. It crackled with magnetic energy, wrapped in a protective shield as strong as Earth's is today. And here's the problem: something that small shouldn't have been able to generate that kind of power. Magnetic fields are born from motion, specifically the churning of molten metal in a planet's core. The bigger the world, the longer it takes to cool, and the more time its magnetic engine has to keep running. Earth's dynamo still hums along because our planet is massive enough to retain its inner heat. But the moon, it's a fraction of Earth's size. By all rights, its core should have frozen solid eons ago, leaving no way to sustain a magnetic field. Yet ancient moon rocks collected during the Apollo missions tell a different story. Trapped inside their crystals are tiny magnetic imprints, proving that between 3.5 and 4 billion years ago, the moon's magnetism rivaled our own. So how did this happen? One leading theory points to a cosmic dance with Earth. Early in their history, the moon orbited much closer to our planet. Some scientists argue Earth's gravity could have stretched and squeezed the moon's core like putty, stirring its molten iron into a temporary dynamo. Think of it like kneading dough. The friction generates heat, keeping the core active far longer than it should have been. Others propose a more violent origin. Colossal asteroid impacts during the moon's chaotic youth might have blasted enough energy into its interior to jumpstart the magnetic field, like a hammer striking a bell and setting it ringing. But there's a catch. Recent simulations suggest even these explanations may not be enough. The moon's field lasted for over 1 billion years, far too long for impact energy or tidal heating alone to sustain it. That's led to a radical alternative. What if the moon's core wasn't just molten iron? Some researchers speculate it might have contained lighter elements like sulfur, lowering the melting point and allowing the dynamo to persist long after it should have shut down. Others wonder if the moon's mantle played a role, with heat from radioactive elements creating currents that amplified the magnetic effect. The implications stretch beyond lunar history. If small worlds can generate strong magnetic fields, it changes how we search for habitable exoplanets. Earth's field protects us from deadly solar radiation. Could moon-like dynamos have shielded ancient life on other tiny worlds? Or was the moon's magnetism a fluke, a perfect storm of conditions impossible to replicate? Every rock we study, every simulation we run, chips away at the mystery. But one thing's certain: the quiet moon we see today was once a powerhouse, and its secrets are still buried in the dust beneath our feet. If you think space is uniformly cold, think again. There's a patch of sky so unnaturally frigid it defies explanation. A cosmic cold spot lurking in the afterglow of the Big Bang itself. Discovered in 2004, this eerie void in the cosmic microwave background, the CMB, isn't just a little cooler than its surroundings. It's a staggering 70 microkelvin colder, a temperature drop so dramatic it's like finding a frozen lake in the middle of a desert. Scientists call it the cold spot, and it's one of the most perplexing wrinkles in our map of the early universe. What makes this anomaly so baffling is its sheer scale. Stretching nearly 2 billion light-years across, the cold spot isn't just empty, it's a supervoid, a region of space where galaxies and galaxy clusters are suspiciously scarce. Normally, such voids explain minor temperature dips in the CMB, a phenomenon known as the integrated Sachs-Wolf effect. But here's the catch: the cold spot is too big, too cold, and too isolated to fit that model. The math just doesn't add up. Even if this were the largest void in existence, it shouldn't have caused such an extreme temperature drop. That's where things get wild. Some cosmologists suggest this might be evidence of a cosmic collision, a bruise left behind when our universe bumped into another bubble in the multiverse. Picture soap bubbles floating in a sink. If two touched briefly before separating, the point of contact might leave a lingering distortion. If true, the cold spot could be our first glimpse of a parallel universe brushing against ours in the unimaginably vast cosmic foam. Others propose even stranger origins. Could this be the imprint of a primordial defect in spacetime itself? Theories like cosmic textures, knots in the fabric of reality formed during the universe's violent birth, predict regions where space would stretch or twist in ways that leave behind cold anomalies. Or perhaps it's a flaw in our understanding of dark energy, a sign that its mysterious repulsive force isn't as uniform as we've assumed. But here's the twist: not everyone believes the cold spot is real. Skeptics argue it might just be a statistical fluke, a cosmic mirage amplified by our limited perspective. After all, the CMB is a noisy map, and anomalies can emerge purely by chance. Yet, even after multiple surveys and simulations, the cold spot refuses to vanish. It's still there, chilling quietly in the data, daring us to explain it. Whether it's a window into the multiverse, a relic of the Big Bang's aftermath, or simply a trick of the light, the cold spot forces us to confront how much we still don't understand about the universe's infancy. And until we crack its code, this frozen enigma will keep haunting our cosmic maps, a silent reminder that even in the afterglow of creation, mysteries linger in the cold. Most nebulae in the cosmos swirl like spilled paint across the void, chaotic, organic, and beautifully unpredictable. But one celestial structure breaks all the rules, standing out like a geometric masterpiece against the cosmic canvas. Meet the Red Rectangle Nebula, a glowing puzzle of near-perfect symmetry that has baffled astronomers since its discovery. Located about 2,300 light-years away in the constellation Monoceros, this eerie structure shouldn't exist. Nebulae are born from the explosive deaths of stars or the turbulent winds of young ones' processes that don't usually create straight lines or right angles. Yet here it is, a glowing X-shape framed by what looks like a crimson-hued rectangle, as if some cosmic architect drafted it with a ruler. At the heart of this anomaly lies HD 44179, a binary star system where two aging suns orbit each other in a tight, slow dance. These stars are the likely sculptors of the nebula, but how they carved such precise shapes remains a mystery. The prevailing theory suggests their mutual orbits create opposing jets of gas and dust ejected in symmetrical cones. From our vantage point, these cones overlap, creating the illusion of a rectangle. But that explanation only raises more questions. Most bipolar nebulae structures formed by dual outflows show wispy, curved lobes, not sharp edges. The red rectangle's crisp geometry defies the usual turbulence of stellar winds, almost as if physics itself hesitated to blur the lines. Then there's the color. The nebula's deep red glow comes from a rare form of carbon-rich molecules called polycyclic aromatic hydrocarbons, lit up by the star's ultraviolet radiation. These same compounds are found in soot and interstellar dust, but nowhere else do they arrange themselves with such eerie precision. Some researchers speculate that magnetic fields, twisted by the binary star's motion, could be guiding the particles into these unnatural formations. Others wonder if we're seeing the aftermath of a stellar collision, where debris was flung outward in perfectly opposing directions. But the biggest enigma isn't just the shape, it's the timing. The red rectangle is a protoplanetary nebula, a fleeting phase in a star's death throes that lasts just a few thousand years. In cosmic terms, that's a blink of an eye. Catching it in this brief window feels like stumbling upon a sand mandala moments before the wind scatters it. and that's what makes this nebula so mesmerizing. It's not just an outlier, it's a cosmic snapshot of symmetry in a universe that thrives on chaos, a reminder that even in the depths of space, nature occasionally drafts with straight edges, and we have no idea why. Saturn's North Pole hides a geometric marvel so precise, it looks like it was carved by celestial machinery, a gargantuan, six-sided storm known simply as the hexagon. Stretching 20,000 miles wide, with winds screaming at over 200 miles per hour, this swirling vortex isn't just a temporary weather oddity. It's been raging for at least 4 decades, possibly centuries, defying every expectation of how fluids behave in nature. Hurricanes on Earth are chaotic spirals. Jupiter's storms are turbulent ovals, but Saturn, it's crowned by a near-perfect hexagon, a shape more at home in a geometry textbook than the heart of a gas giant's maelstrom. The first hints of this anomaly came in the 1980s when Voyager's grainy snapshots revealed something bizarre at Saturn's pole. But it wasn't until Cassini arrived in 2004 that the hexagon's true strangeness came into focus. Infrared and visible light images showed a honeycomb-like structure so stable, its sides remained razor-sharp even as hurricanes inside churned like boiling water. Even more baffling, the entire hexagon rotates in sync with Saturn's deep interior, completing a full turn every 10 hours and 39 minutes, as if locked into some unseen cosmic clockwork. So how does a storm like this form? Fluid dynamics offers clues but no definitive answers. In lab experiments, swirling liquids can sometimes produce polygonal shapes when layers move at different speeds. Saturn's atmosphere is a vast ocean of hydrogen and helium, with jet streams that might create shear forces capable of sculpting straight edges. Some models suggest the hexagon is a standing wave, a stable pattern born from the interplay between Saturn's rotation and the turbulence beneath its clouds. Think of it like water spiraling down a drain, but on a planetary scale where the planet's own spin twists the chaos into order. Yet even these theories fall short. No other planet, not even turbulent Jupiter, exhibits anything like this hexagonal precision. Earth's polar vortices are messy and transient. Neptune's dark spots come and go. The hexagon, by contrast, is a near-permanent fixture, its angles stubbornly crisp despite the chaos around it. That's led to wilder speculations. Could Saturn's internal magnetic field, asymmetrical and poorly understood, be shaping the storm from within? Or is there some exotic form of convection, unique to Saturn's layered atmosphere, that stabilizes the structure? The hexagon isn't just a curiosity, it's a test, a challenge to our understanding of fluid mechanics on scales we can't replicate in any lab. Every time we think we've pinned it down, it throws another question back at us. Why 6 sides? Why not 8 or 4? Why does it persist while every other storm in the solar system drifts, fractures, or fades? Until we can peer deeper beneath Saturn's golden clouds, the hexagon remains a haunting reminder. Even the laws of physics can carve mysteries we're only beginning to measure. For centuries, stargazers in dark sky locations have witnessed an eerie phenomenon. A faint, ghostly glow stretching up from the horizon just after sunset or before dawn. This luminous pyramid of light, often mistaken for twilight, traces the path of the planets along the ecliptic plane. Astronomers call it the zodiacal light, and while it's long been attributed to sunlight reflecting off cosmic dust between the planets, this explanation hides a glaring inconsistency. The light isn't behaving the way it should. The conventional story goes like this. Over billions of years, asteroids colliding and comets shedding material have filled the inner solar system with fine dust particles. These tiny fragments, no larger than grains of sand, form a vast lens-shaped cloud centered on the sun. When sunlight hits them just right, they create that signature glow. Simple, elegant, except the math doesn't quite add up. Modern observations show the zodiacal light is brighter, smoother, and more evenly distributed than any dust model predicts. If it were just random debris, we'd expect patchiness, variations in brightness, and telltale clumps where asteroids are most active. Instead, the glow is eerily uniform, as if someone took a cosmic paintbrush and stroked it evenly across the sky. That uniformity has sent scientists scrambling. One radical theory suggests the dust isn't just drifting aimlessly. It might be trapped in orbital resonances with planets, herded into stable zones like sheep guided by invisible fences. Jupiter, with its monstrous gravity, could be corralling particles into a smoother distribution than nature would allow on its own. Others propose the dust isn't ancient at all, but constantly replenished by a previously unnoticed population of micrometeoroids, perhaps from a recent breakup of a large comet or asteroid. But the most spine-tingling idea, some of that dust might not be dust at all. In 2021, NASA, a New Horizons probe now far beyond Pluto, made a startling observation. Even out in the freezing depths of the Kuiper Belt, the background glow of the zodiacal light persists far from the Sun, where interplanetary dust should be vanishingly sparse. That raises an electrifying possibility. What if part of this light comes from something beyond our solar system? Tiny particles from interstellar space, or even the faint echoes of distant, unseen matter, could be mingling with our local dust, amplifying the glow in ways we never anticipated. The zodiacal light isn't just a celestial curiosity. It's a mirror held up to our ignorance for something so visible, so persistent, we still can't fully explain its origins. And that's the beauty of it, a reminder that even the most familiar glows in the night sky can harbor secrets we're only beginning to uncover. At the heart of our galaxy, something invisible is screaming into the void, a torrent of gamma rays with no clear source, blazing from the darkness where telescopes can't see. Scientists call it the galactic center excess, and it's one of the most hotly debated anomalies in modern astrophysics. Imagine pointing a gamma-ray detector toward the Milky Way's core and finding not just the expected radiation from known objects, but an unexplained glow, a persistent hum of high-energy light that shouldn't be there. This isn't a flicker or a burst, it's a steady, ominous excess like a shadow that shines too brightly. The discovery came in 2009 when NASA, a Fermi gamma-ray space telescope, began mapping the galaxy's gamma-ray emissions. Right away, researchers noticed something odd. The center of the Milky Way was radiating far more gamma rays than could be explained by ordinary cosmic processes, supernova, pulsars, or even the supermassive black hole Sagittarius, a star, which sits relatively quiet compared to other galactic cores. The excess forms a rough sphere around the galactic center, stretching thousands of light years in every direction with no obvious engine at its heart. One tantalizing explanation involves the most elusive substance in the universe, dark matter. Theorists suggest that if dark matter consists of weakly interacting massive particles, WIMP, they could annihilate upon collision, transforming into gamma rays in a flash of self-destruction. The galactic center, with its dense concentration of dark matter, would be the perfect furnace for this invisible fireworks show. The energy signature even matches some predictions, like a lock fitting a key we've never seen. But not everyone's convinced. Skeptics point to a cosmic coincidence: millisecond pulsars, the rapidly spinning corpses of dead stars, also emit gamma rays in similar patterns. These ultra-dense objects are notoriously difficult to spot unless their beams of radiation happen to point directly at Earth. Could the excess simply be the combined glow of thousands of hidden pulsars, their lighthouse-like signals blurred into a fog by distance? Some studies claim to have detected faint point sources within the excess, hinting at this very possibility. Others argue the distribution is too smooth, too uniform to come from discrete objects. The debate rages because the stakes are so high. If this is dark matter's calling card, it could be the breakthrough physicists have waited decades for a way to finally pin down the nature of the universe's missing mass. But if it's pulsars, it means we've underestimated just how many of these stellar zombies lurk in the galactic shadows. Either way, the galactic center excess forces us to confront how little we truly know about the universe's brightest dark corners. And until we send sharper eyes into the void, this gamma-ray riddle will keep burning at the heart of everything. Most of the universe is crowded with galaxies, swirling in clusters and superclusters like foam on an endless ocean. But in the constellation Boots, there's a hole in the cosmic fabric, a staggering void so vast and empty it defies belief. Stretching an incomprehensible 330 million light-years across, the Boots void isn't just a gap. It's a cosmic desert, a region of space where galaxies are almost entirely absent. If you were to stand at the center of this void and look up, the night sky would be nearly black, with only a handful of distant stars piercing the darkness. At first glance, this shouldn't exist. According to our best models of the universe's structure, matter should be distributed fairly evenly on the largest scales, like a web of light and dark matter stretching across existence. The Boots void throws that assumption into question. Astronomers have catalogued fewer than 60 galaxies in this enormous space, a fraction of what you'd expect in a region that size. To put it in perspective, a typical chunk of the universe that large should contain at least 10,000 galaxies. So where did they all go? Some researchers argue this might just be an extreme statistical fluke, a rare but possible quirk in the cosmic lottery. After all, randomness can produce outliers, and the universe is nothing if not vast, but others suspect something more profound at work. Could this void be evidence of an ancient collision between our universe and another? Theories of the multiverse suggest that if bubble universes occasionally brush against one another, the energy released could carve out regions of space, pushing matter away like ripples in a pond. The Boots void might be the scar left behind. Then there's the dark energy angle. This mysterious force driving the universe's accelerated expansion might operate unevenly in certain regions, creating pockets of exaggerated emptiness. If dark energy behaves differently under extreme conditions, voids like Boots could be testing grounds for physics we've barely begun to imagine. But the most unsettling possibility, we might be seeing the imprint of something even stranger: primordial black holes from the universe's infancy, so massive and ancient that they devoured entire swaths of galaxies long before stars as we know them even formed. These hypothetical monsters, if they exist, could have cleared the void like cosmic vacuums, leaving behind only echoes of their feast. The Boots void doesn't just challenge our maps of the cosmos. It forces us to ask whether we've fundamentally misunderstood the rules. Is it a statistical anomaly, a cosmic accident, or is it a clue, a whisper from the edges of known physics, hinting at forces and histories we've yet to uncover? Every telescope pointed at this emptiness brings us closer to an answer, or deeper into the mystery. Deep in the calculations of cosmic inventory, something doesn't add up, a discrepancy so glaring it's been dubbed the missing baryon problem. Baryons, the particles that make up ordinary matter like protons and neutrons, should account for about 5% of the universe's total mass energy, according to our best models. Yet when astronomers tally up all the visible stars, galaxies, and gas clouds, they come up short. Nearly half the baryons seem to be missing. It's as if the universe misplaced an entire reservoir of its building blocks, and the hunt to find them has led to one of the most intriguing detective stories in modern cosmology. So where could all this matter be hiding? The leading suspect is an elusive cosmic web known as the Warm-Hot Intergalactic Medium, or WIM. Picture this: the universe isn't just empty space dotted with galaxies. It's threaded with vast, invisible filaments of superheated gas, stretching between clusters like a spider's silk. These tendrils are so diffuse, they don't emit much light, but they're scorching, with temperatures reaching hundreds of thousands to millions of degrees. At those extremes, the gas glows faintly in X-rays, making it nearly impossible to detect with traditional telescopes. That's where space observatories like Chandra and XMM Newton come in. By scanning the skies in X-ray wavelengths, they've begun to tease out hints of this hidden matter. In 2018, astronomers made a breakthrough. Using the way distant quasars backlit these filaments like shining a flashlight through fog, they found signatures of highly ionized oxygen, a tracer of the whim-searing hot gas. The numbers started to add up. If these faint, sprawling tendrils exist in the predicted quantities, they could account for a significant chunk of the missing baryons. But the mystery isn't fully solved. Some of these baryons might be even harder to pin down, lurking in low-density regions where the gas is too cool to emit X-rays yet too warm to absorb light like cold hydrogen clouds. Others could be tied up in elusive forms like rogue planets drifting between stars or faint, ultra-diffuse galaxies that evade detection. There's even a wild card. Could some baryons have been ejected into intergalactic space by violent events like supernova explosions or black hole jets, scattered so far they've blended into the cosmic background? The implications stretch beyond just balancing the cosmic books. If baryons are hiding in these hard-to-see corners, it means the universe's structure is far more intricate than we've mapped. The WIM filaments could be the highways along which galaxies form and evolve, the unseen scaffolding shaping everything we do observe. And if we're still missing a fraction of these particles, it might hint at gaps in our understanding of how matter behaves under extreme conditions, or even point to new physics lurking in the voids. The missing baryon problem reminds us that the universe doesn't give up its secrets easily. Even the stuff we're made of, the ordinary matter we thought we knew, can vanish into the cosmic shadows when we're not looking. And that's the thrill of the hunt. Each discovery pulls back another layer, revealing just how much we still have to learn about the web we're all woven into. Even the afterglow of the Big Bang has its quirks, and none are more unsettling than what cosmologists call the axis of evil. This ominous-sounding anomaly isn't some cosmic supervillain. It's a bizarre alignment in the cosmic microwave background, the CMB, that shouldn't exist. The CMB is the oldest light in the universe, a snapshot of the infant cosmos just 380,000 years after the Big Bang. In theory, its temperature fluctuations should be randomly scattered like static on an old TV. But when scientists mapped this primordial glow, they noticed something spine-tingling. Those fluctuations weren't random at all. They appeared to line up eerily with the plane of our solar system, as if the universe itself had drawn a bullseye around us. This discovery sent shockwaves through cosmology because it violates a sacred principle, the Copernican idea that Earth holds no special place in the cosmos. The CMB should look roughly the same in all directions, with no preferred axis. Yet multiple studies, including data from NASA, WMAP, and ESA's Planck satellites, confirm the alignment exists. Some researchers argue it's just a fluke, a statistical mirage amplified by our limited vantage point. But the odds of such a perfect alignment happening by chance are less than 1 in 1,000, turning this into a full-blown crisis for modern astrophysics. Could there be a more mundane explanation? Skeptics point to subtle errors in how we subtract the Milky Way's foreground emissions from CMB data. Our galaxy's dust and magnetic fields might imprint false patterns on the maps, creating the illusion of an axis. Others suggest the solar system's motion through space, a blistering 2 million miles per hour toward the constellation Leo, could stretch the CMB's photons in a way that mimics alignment. But the wildest theories go much further. Some physicists speculate this could be evidence of a pre-Big Bang universe, a relic structure that survived the birth of our cosmos. Others wonder if it's a sign of cosmic topology, that space itself might be shaped like a vast, twisting donut on scales larger than we can observe, warping the CMB into unexpected geometries. The most radical idea, that we're seeing the fingerprints of another universe bumping against ours in the multiverse, leaving a mark we're only now learning to read. The axis of evil isn't just a curiosity, it's a direct challenge. Either we've misunderstood something fundamental about the universe's birth, or we're staring at the first clue of physics beyond our current theories. And until we crack this code, this eerie alignment will keep haunting cosmology, a silent reminder that even our deepest cosmic maps might still be missing the big picture. Black holes are supposed to be cosmic titans, monstrous voids with gravity so strong not even light can escape. But in the constellation Monoceros, just 1,500 light-years from Earth, astronomers may have found the impossible. A black hole so small, it defies everything we thought we knew about how these beasts form. Nicknamed the unicorn, this mysterious object weighs in at just 3 times the mass of our Sun, teetering on the edge of what physics says should exist. The unicorn isn't like the supermassive black holes lurking at galaxy centers or even the stellar mass ones formed by collapsing stars. It's something else entirely, a misfit that shouldn't be able to survive. According to conventional models, when a massive star dies, it either explodes as a supernova, leaving behind a dense neutron star, or collapses into a black hole if its core is heavy enough. But there's a catch. The math says black holes shouldn't form below about 5 solar masses. Below that, neutron stars dominate, yet the unicorn sits stubbornly in this forbidden zone, whispering that our rulebook might be missing a few pages. So how did this cosmic runt end up existing? One possibility is that it's the stripped-down corpse of a once larger star. In binary systems, a hungry companion can siphon off layers of gas, leaving behind a dense core too slight to collapse under normal circumstances, but under exotic conditions, maybe physics bends the rules. Another theory suggests it could be a primordial black hole, a relic from the universe's first chaotic seconds, when density fluctuations might have birthed tiny black holes by the trillions. The real kicker, we haven't even seen the unicorn directly. Its presence is inferred from the bizarre dance of its companion star, a red giant whose light stretches and dims in ways only an invisible, ultra-dense object could explain. If confirmed, this pint-sized predator would rewrite stellar graveyard rules, proving that black holes can exist in sizes we never dreamed possible. What's thrilling isn't just the unicorn's defiance, it's what it implies. If black holes can be this small, they might be far more common than we realized, hiding in plain sight where we never thought to look, and that changes everything. For decades, we've scanned the skies for black holes as colossal landmarks, but the universe, it seems, has been quietly breeding unicorns. Among all the cosmic mysteries, none is more profound or more unsettling than the universe's accelerating expansion. Imagine throwing a ball into the air only to watch it fly faster and faster into the sky, defying gravity's pull. That's precisely what's happening on the grandest scale imaginable. Galaxies aren't just drifting apart, they're fleeing from one another at speeds that increase with every passing moment, as if some unseen hand is stretching the fabric of space itself. This bizarre phenomenon is driven by a force so enigmatic, scientists still refer to it by a placeholder name, dark energy. The discovery of dark energy shook cosmology to its core. In the late 1990s, astronomers studying distant supernova made a startling observation. These cosmic explosions, used as standard candles to measure vast distances, were fainter than expected, meaning space had stretched more than predicted since their light began its journey. The conclusion was inescapable. The universe's expansion wasn't slowing down as gravity should dictate, it was speeding up. This revelation earned researchers the 2011 Nobel Prize in Physics, but it left behind an even bigger question. What exactly is dark energy? The simplest explanation invokes Einstein's cosmological constant, a term he originally inserted and later dismissed into his equations to describe a static universe. In this view, dark energy is the energy of empty space itself, a constant force woven into the vacuum that never dilutes, no matter how much the universe expands. It's elegant but problematic. Quantum field theory predicts a vacuum energy density astronomically larger than what we observe, off by a factor of 10 to the power of 120. That's the worst theoretical mismatch in science, suggesting we're missing something fundamental. Enter quintessence, a more dynamic alternative. Unlike the cosmological constant, quintessence proposes that dark energy is a field permeating space, one that evolves over time. Picture it like an invisible fluid filling the cosmos, its pressure and density shifting as the universe ages. Some models even suggest quintessence could interact with dark matter or ordinary particles in subtle ways, opening doors to exotic physics beyond our current theories. But here's the catch: no direct evidence for quintessence exists, and its proposed properties remain purely speculative. Then there are the wild cards. Could dark energy signal a breakdown in Einstein's general relativity on cosmic scales? Modified gravity theories like Big Cousin, TVS, attempt to explain the acceleration without invoking dark energy at all, though none have yet matched observations as cleanly as the standard model. Others wonder if we're seeing the echo of a prior universe, with cyclic cosmologies proposing that dark energy is the precursor to a future big crunch or bounce. The stakes couldn't be higher. Dark energy isn't just some curious anomaly, it makes up 68% of the universe's total energy budget. It's the dominant force shaping our cosmic fate, steering everything toward a distant, frigid emptiness where galaxies vanish over the horizon of perception. And yet, after decades of searching, we're no closer to understanding what it truly is. Every telescope, every simulation, every desperate theoretical tweak brings us face to face with the same humbling truth. The universe is accelerating, and we're still just guessing why. That's the dark energy enigma, not just a puzzle to solve, but a mirror held up to the limits of human knowledge itself. Mars has been playing a dangerous game of hide and seek with scientists for years, and the stakes couldn't be higher. The mystery revolves around fleeting bursts of methane gas detected in the planet's thin atmosphere, a puzzle that has divided researchers into two camps: those who believe it could be a sign of hidden life, and those convinced it's just another geological quirk of the red planet. The saga began in 2013 when NASA Curiosity rover, crawling through Gale Crater, caught its first whiff of the gas. Methane is a big deal because on Earth, 95% of it comes from living organisms, everything from burping cows to subterranean microbes. Even more intriguing, the readings weren't steady. They spiked unpredictably, sometimes hitting levels 10 times higher than baseline before vanishing without a trace. It was as if Mars was exhaling secrets in brief, tantalizing breaths. But here's where the plot thickens. While Curiosity kept sniffing out these erratic methane bursts, the European Space Agency's Trace Gas Orbiter, a satellite specifically designed to monitor Martian gases, found nothing. Zilch, not a single trace of methane in the global atmosphere. How could two highly advanced instruments, one on the ground and one in orbit, deliver such contradictory results? One theory suggests the methane might be trapped beneath the surface, seeping out in tiny, localized plumes that Curiosity happens to drive through, plumes too small or short-lived for an orbiting satellite to spot. Picture a slow leak in a pipe, with a rover occasionally passing directly under the drip. Another idea points to destruction. Maybe the methane is being rapidly broken down by ultraviolet radiation or chemical reactions in the soil before it can spread high enough for the orbiter to detect. Some researchers even speculate that the gas could be locked inside ice or minerals, only released when temperature changes or meteorite impacts fracture the ground. Then there's the life question. If microbial organisms exist deep underground, protected from radiation and extreme cold, they could be producing methane as a byproduct, just like Earth's extremophiles do in caves and hydrothermal vents. But abiotic processes can't be ruled out. Mars has active geology with serpentinization, a reaction between water, carbon dioxide, and certain rocks, known to produce methane without any biology involved. The mystery deepens when you consider timing. Some of Curiosity's methane spikes seem to follow seasonal patterns, peaking in the northern summer. If that's true, it hints at a cycle, may be tied to temperature shifts freeing trapped gas or even, wildly, to dormant microbial activity ramping up in warmer months. Until we drill deeper or send instruments specifically designed to trace these emissions, the methane spikes will remain one of Mars' most compelling riddles. Are they geological hiccups or faint signatures of life next door? The answer might rewrite our place in the cosmos or remind us just how clever a dead planet can be. Venus has always been Earth's twisted twin, a scorching, toxic hellscape shrouded in thick sulfuric clouds. But in 2020, this planetary sibling shocked the world when scientists detected traces of phosphine floating high in its atmosphere, a gas that on Earth is almost exclusively produced by living organisms. For a brief, electrifying moment, it seemed we might have found our first hint of extraterrestrial life right next door. The discovery came from a team using the James Clerk Maxwell Telescope in Hawaii and later confirmed by the Atacama Large Millimeter Array in Chile. These instruments picked up the spectral fingerprint of phosphine at concentrations of about 20 parts per billion, a tiny amount but far higher than any known abiotic process on Venus should produce. On Earth, phosphine comes from microbes thriving in oxygen-free environments like swamps or the guts of animals. The idea that similar organisms might be floating in Venus's temperate cloud layers, 50 kilometers above the surface where pressures and temperatures are eerily Earth-like, set the scientific community ablaze with excitement. But the euphoria didn't last. Almost immediately, other researchers raised red flags. Some questioned the data itself, suggesting the signal might have been misidentified. Sulfur dioxide, a common Venusian gas, can mimic phosphine's spectral signature under certain conditions. Others argued that even if the detection was real, there had to be a non-biological explanation. Volcanic activity, lightning, or chemical reactions with Venus's bizarre atmospheric compounds could, in theory, produce phosphine without invoking life. The debate grew hotter than Venus's surface. Proponents of the life hypothesis pointed out that no known geological or chemical process on Venus could generate phosphine at the observed levels. They even proposed mechanisms for how microbes could survive in the planet's acidic clouds, perhaps encased in protective droplets or riding atmospheric currents like aerial plankton. Skeptics fired back with alternative models showing how minerals ejected from Venus's surface might react with sulfuric acid to form phosphine under extreme conditions, a purely chemical fluke. Then came the real twist. Follow-up observations failed to consistently replicate the original phosphine detection. Some studies found nothing at all, while others saw only ambiguous traces. The uncertainty left the door open for both sides. Was the phosphine real but intermittent, hinting at a dynamic, living process? Or had the initial reading been an illusion, a case of wishful thinking amplified by noisy data? The truth remains unresolved, and that's what makes this anomaly so gripping. Venus, long dismissed as a lifeless furnace, suddenly became a frontier, a place where the rules might not be as absolute as we thought. Whether the phosphine turns out to be a false alarm or the first whisper of life beyond Earth, it's a reminder that even our closest planetary neighbors still guard their secrets fiercely. And sometimes the most tantalizing clues are the ones that refuse to be easily explained. Beyond the orbit of Neptune, where the solar system's light fades to a dim whisper, lies a cosmic junkyard of icy leftovers, the Kuiper Belt. This vast ring of frozen debris, home to Pluto and thousands of other dwarf planets, should stretch smoothly outward, with objects gradually thinning as distance increases. But something bizarre happens around 50 astronomical units from the Sun, a boundary so abrupt, astronomers call it the Kuiper Cliff. It's as if someone built a celestial fence beyond which the debris simply stops. This isn't just a gradual tapering. Observations reveal a staggering drop-off in Kuiper Belt objects past this point, far steeper than any standard model predicts. Imagine walking along a beach where the sand suddenly vanishes into a sheer drop, no gentle slope, just an edge. One moment you're counting dozens of icy bodies, the next the cosmic cupboard is nearly bare. The most obvious culprit, a hidden planet lurking in the darkness, its gravity sweeping the area clean like a cosmic bulldozer. The idea of a distant, undiscovered world isn't new. Planet 9, a hypothetical giant orbiting hundreds of away, has been proposed to explain odd clustering in some Kuiper belt objects' orbits, but the Kuiper cliff adds fuel to the fire. If a massive planet exists, its gravitational pull could have shepherded objects inward, leaving a stark void beyond its influence. Picture a shepherd moon corralling ring particles, but on a solar system-wide scale. The math suggests a planet roughly 5 to 10 times Earth's mass could create such a sharp boundary, though no direct evidence has been found yet. Not everyone's convinced. Alternative theories point to the solar system's violent infancy. During formation, perhaps gravitational interactions with a rogue star or a passing interstellar object stripped away the outer Kuiper belt, leaving only debris closer to the Sun. Others speculate that primordial conditions like a dense birth cloud or an early imbalance in planetary migration could have sculpted this edge naturally. There's even a radical idea. The cliff marks where the Sun's protoplanetary disk simply ran out of material, a fossilized relic of our system's growth spurt 4.5 billion years ago. The enigma deepens when you consider timing. The New Horizons probe, which flew past Pluto in 2015, is now venturing beyond the Kuiper cliff, offering our first close-up look at this mysterious frontier. Early data hints at unexpected structures, clusters of small objects that shouldn't exist if the region were truly empty. Could these be stragglers, survivors of whatever process cleared the rest? Or signs of something else entirely? What's captivating isn't just the mystery itself, but what it says about our place in the cosmos. The Kuiper cliff forces us to confront how little we truly know about our own backyard. Is it a signpost to an unseen world, a scar from ancient chaos, or something we haven't even imagined? Until we peer deeper into the dark, this frozen edge will remain one of the solar system's most tantalizing puzzles. A silent boundary where the known universe seems to hold its breath. Every measurement in science comes with a margin of error, a little wiggle room where the truth might hide. But what happens when two of the most trusted tools in cosmology give answers so far apart? The gap can't be brushed aside as mere uncertainty. That's the heart of the Hubble tension, a stubborn rift in our understanding of the universe's expansion that's forcing astronomers to question whether we've missed something fundamental about how reality works. On one side, we have the cosmic distance ladder, a meticulous chain of measurements using pulsating stars called Cepheids and cataclysmic supernova to gauge how fast galaxies are racing away from us. This painstaking method, refined over decades, gives us what's known as the Hubble constant, approximately 73 kilometers per second per megaparsec. That means for every additional megaparsec of distance, a mind bending 3.26 million light-years, a galaxy moves 73 kilometers per second faster away from us. But there's another way to pin down this number, and here's where the plot thickens. By studying the cosmic microwave background, the faint glow of the infant universe, scientists can extrapolate how fast space should be expanding today based on the physics of the Big Bang. These pristine measurements, courtesy of the Planck satellite, peg the Hubble constant at around 67. The difference seems small, but the implications are colossal. We're not talking about a rounding error. These results disagree by nearly 10%, a chasm too wide to dismiss, especially when both methods have been checked and rechecked to the point of exhaustion. So what's really going on? One camp argues for hidden systematic errors, tiny biases creeping into our measurements like fingerprints on a lens. Maybe Cepheid stars aren't the perfect yardsticks we thought, their pulsations subtly influenced by dust or metallicity. Or perhaps the Planck data is skewed by some unaccounted-for anomaly in the early universe's structure. But after years of scrutiny, no one's found a smoking gun. The discrepancies persist, stubborn as gravity itself. That's led to more radical possibilities. Could dark energy, the mysterious force accelerating the universe's expansion, be changing over time? Most models treat it as a constant, but if it's evolved since the Big Bang, that might explain why early and modern measurements don't align. Others speculate about exotic forms of dark matter interacting in ways we haven't predicted, or even modifications to Einstein's theory of gravity itself. Imagine if the rules of relativity start bending on cosmic scales, like a game of telephone where the message changes slightly over vast distances, the most electrifying idea. That we're seeing hints of undiscovered particles, perhaps relics from the universe's first seconds, that altered the expansion rate in ways our textbooks never anticipated. It wouldn't be the first time a discrepancy in the data led to a revolution. In the 19th century, the anomalous orbit of Mercury exposed flaws in Newtonian physics, paving the way for general relativity. The Hubble tension could be our modern Mercury moment, a cosmic breadcrumb pointing toward physics beyond the standard model. Yet for all the theories, the tension remains, tightening with each new observation. Future telescopes like the James Webb Space Telescope and the Vera Rubin Observatory will scrutinize these numbers with even sharper eyes, hunting for clues we might have missed. Until then, this isn't just a disagreement about digits, it's a live wire crackling with possibility. Because when the universe gives you two different answers to the same question, it's usually not a mistake. It's a message, and decoding it might just rewrite the story of everything. Some inventions are so revolutionary they change the course of history. Others are so baffling they threaten to rewrite the laws of physics themselves. The M drive falls squarely in the second category, a propulsion system that claims to generate thrust without expelling any fuel, defying Newton's third law with every pulse of its microwaves. If it worked as advertised, this unassuming copper cone could revolutionize space travel, whisking astronauts to Mars in weeks without the need for massive fuel tanks. But here's the catch. According to everything we know about motion and momentum, the M drive shouldn't work at all. The story begins in the early 2000s when British engineer Roger Scheuer first proposed the concept. The design was deceptively simple, a tapered, sealed cavity where microwaves bounce back and forth. Scheuer claimed this created an imbalance in radiation pressure, producing a tiny but measurable thrust toward the narrow end of the cone. No propellant, no exhaust, just pure, inexplicable motion. Skeptics dismissed it as fantasy, but then something unexpected happened. Independent labs, including NASA EagleWorks team, reported detecting thrust in their own M drive tests. Not much, just micronewtons, barely enough to nudge a sheet of paper, but enough to send shockwaves through the scientific community. Critics were quick to pounce. Physics textbooks state unequivocally that for every action, there must be an equal and opposite reaction. Rockets push exhaust backward to move forward, cars push against the road. The M drive, by contrast, seemed to pull thrust out of thin air, like a car moving forward without its tires touching the ground. Some researchers argued the observed thrust was merely experimental error, thermal expansion of the device, interactions with Earth's magnetic field, or even subtle vibrations fooling the instruments. Others dug deeper, suggesting quantum effects or interactions with virtual particles in the vacuum might explain the anomaly. The debate reached a boiling point when a team at TU Dresden built a super-sensitive test rig in 2021 designed to eliminate every possible source of interference. Their result, no thrust. The M drive, it seemed, had finally been debunked. Yet even this wasn't the end of the story. Supporters pointed out that the Dresden test used a different cavity design, leaving room for doubt. Meanwhile, a Chinese team claimed success with their own version in 2022, reigniting the controversy. What makes the M drive so captivating isn't just the technical argument, it's what it represents. At its core, this is a clash between two worldviews. one that insists our understanding of physics is essentially complete, and another that dares to ask if we've missed something fundamental. Every failed replication chips away at the dream, but every ambiguous result keeps the door slightly ajar. Perhaps the M drive is a modern-day perpetual motion machine, destined for the scrap heap of defunct ideas. Or perhaps hidden in those disputed micronewtons lies a clue to a deeper truth, one that could unlock the stars. Until then, this copper cone remains a testament to humanity's audacity, a reminder that even the most entrenched laws of nature are worth questioning. From the silent scream of the wow signal to the eerie perfection of Saturn's hexagon, these 25 cosmic anomalies aren't just oddities, they're humbling reminders of how much we still don't know. Think about that. We've mapped the microwave glow of the Big Bang, traced the orbits of planets light years away, and yet the universe keeps tossing curveballs that leave even the sharpest minds scrambling. Take Tabby's star flickering like a candle in a cosmic wind, or Oumuamua tumbling through our solar system with no clear origin. Consider the Great Attractor dragging thousands of galaxies toward a darkness we can't see, or the cold spot, a frigid void that might be a bruise from another universe. And let's not forget the humble moon, our closest neighbor, hiding secrets about magnetic fields that defy every textbook. These aren't just gaps in our knowledge, they're doorways to discoveries we haven't even imagined yet. What's thrilling isn't just the mysteries themselves, but what they represent. Every unexplained signal, every bizarre alignment, every "that shouldn't be there" moment is an invitation to question, to explore, to rethink what's possible. Maybe one of these anomalies holds the key to dark matter, or the true nature of time, or even proof we're not alone. The only way to find out: keep looking up, keep questioning, and stay relentlessly curious. So tell us, which of these cosmic puzzles fascinates you the most? Is it the haunting silence of the Fermi Paradox, or the way Venus's phosphine teases us with the possibility of life? Drop your favorites in the comments, because the best part of science is the conversation it sparks. And if you're hungry for more deep dives into the universe's unsolved mysteries, hit subscribe and ring the bell. The cosmos isn't done surprising us, and we're not done uncovering its secrets. Together, let's keep unraveling the universe one anomaly at a time.